Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this third lecture of Module 11 on Geomorphology of Sea, Seashore, Shoreline, Engineering Geology, Hazards and Mitigations. In previous lectures we have discussed about generation of waves and basic aspects of sea waves. Now in this new aspect we are going to discuss about wave propagation in different depth of water and about the wave mechanics. In these lectures we are going to elaborate about wave propagation in different depth of seawater. Regarding this we are going to discuss about sea waves and depth concept, then classification of waves, wave shoaling, celerity of waves, etc. Friends, as you know, the ocean waves are induced by wind, and the energy from the wind of offshore is carried out by the waves toward the shore, and the water waves are surface waves as a mixture of longitudinal and transverse waves. The surface waves are deformation of the sea surface. The deformations propagate with the wave speed while the water molecules remain at the same position on average, and the energy moves toward the shore from the deep ocean side, and a piece of floating debris beyond the breakers, it moves toward the shore on crest of the waves and move the same distance backward with trough of the waves. So to and fro type of motion of debris is generally performed with help of sea waves, and finally all the debris move toward the shore side on one side, on another side toward the deep ocean side. The debris moves in a roughly circular path perpendicular to the water interface. As we have already discussed about the generation of sea waves, here again I try to link this aspect with generation of waves. Friends, the wind have fluctuating nature, having pockets of energy. When the wind is going to interact with sea water, then there is a transfer of energy from the wind to the water of sea. This transfer of the energy is actually due to pressure present in wind. So gradually there is transfer of energy due to pressure present in wind to the surface of the sea. Initially the partial amount of energy transferred to the sea surface and started excavating the sea surface. The amount of energy due to pressure present in wind is going to induce the stationary surface in dynamic state, and as a result there is a formation of ripples. The amount of energy due to pressure present in wind initially low in amount, with respect to time then there is increment in amount of energy transfer from wind to the seawater. However, the rate of transfer of energy or transfer of pressure gradually decreases with respect to time. So in deep water there is a development of ripples due to continuous transfer of energy from the wind as well as the interference of the other ripples makes the ripples of higher magnitude with the higher time period, and gradually there is a continuous increase in amplitude of the waves or height of the waves when the water moves from deep sea toward the shore side. When the energy present in waves become equal to the energy present in wind, or the pressure present in wave it become equal to the pressure present in wind, then there is no transfer of energy or no transfer of pressure to the waves. As we have already discussed, there is a continuous decrease in rate of energy or pressure transfer from the wind to the surface of the seawater due to gradually decrease in rate of transfer of energy or pressure at a point may reach at a time when there is no transfer of the energy or pressure from the wind to the oceans. At that time the ocean waves having more height and come toward the shallow sea close to the shore, the waves has more height and passing or reaching the limit of the stability, therefore there is break in the waves. This phenomena is known as wave breaking. Why it occurs? When the sea waters move toward the shore side, then there is a lot of obstacles, barriers present on the bottom of the sea toward the shore, creating lot of drags to the waves which are going to oppose the movement of the waves toward the shore side. However, due to inertia, the waves which are on surfacial parts is moved forward with higher speed and try to make this type of wave in this form. After reaching a certain height, the waves are unable to stabilize themselves, then there is breaking due to effect of gravity. And this zone is recognized as wave breaker zone, which we are also recognized as a surf zone. This generally occurs close to the beach. Next important point, how many types of waves present in seawater? Broadly, 3 types of waves present in seawater, excluding tidal waves, because the contribution of tidal waves are comparatively less in comparison to the wind waves, swells and sea waves due to seismic activity. The wind waves, which is general waves, the wind waves is a surface wave that occurs on the free surface of water as a result of the wind blowing over the water surface, which we have already discussed. The contact distance in the direction of the wind is known as a fletch, which we have already elaborated in our previous discussion. And waves in the sea are moves many kilometers before approaching seashore, and it ranges from small ripples up to wave over 30-meter high. What are the major factors going to influence the wind wave or surface waves? The factors like speed of wind is going to influence, because this type of wind waves is practically assisted by the pressure present in wind. Then duration of the action of the wave due to wind imposed pressure. Then the fletch length, effective contact zone between the surface of the sea and wind, and then depth of the water. These 4 factors is going to influence the wind wave. Swell is slightly bigger waves. A swell is a series of mechanical waves that propagate along the interface between the seawater and the air under the predominantly influence of gravity. Thus, this type of wave is also called as surface gravity waves. A swell consists of wind generated waves that are not greatly affected by the local winds at that time, that induced by the wind during the storms and others. Initially, these waves have their initiation in form of wind waves. Due to continuous transfer of the energy with decreasing rate of transfer of energy, there are the dispersion of the wind waves from detached weather system where the wind flow for a duration of time over a flat water. Therefore, these waves move out from the source area at a speed which is a function of time period and wavelength of wave. So this swell is not dependent on the source and started moving independently. However, the wind waves have connection with the source of initiation. These waves have relatively long wavelength, higher in length, as short wavelength waves carry less energy and dissipate faster, but this varies due to the size, strength and duration of weather system responsible for swell and the size of water body, and varies from event to event and from the same event over time. Sometimes swell longer than 700 meter cause due to severe storm. So swell is a wave which is of higher amplitude and relatively longer wavelength. In addition to this swell, there is another type of wave which have no connection with the wind pressure assisted formation of waves, that is of seismic origin. Here if we are going to see the bottom of the ocean, then in such situation if there is any fault or junction of tectonic plates, then due to movement of tectonic plates there is a generation of seismic waves, or in another words we can say that formation of earthquakes. Due to this, what happens? Due to shift of this column, here we are going to show here shift of this column downwards, the whole mass of the water is suddenly moving downwards. However, relative to this water column, the another water column present nearby the area is feeling imbalance. So what happens? Due to decrease in level of water, the water present here is started moving fastly to fill the gap and reach the equilibrium. On other side, the seismic waves is going to create lot of energy inside the water, and due to agitation of water there is a development of waves other than wind waves. Initially such waves of lesser amplitude, when such type of wave is moving or approaching toward the shore, then there is a continuous increment in height, or in another word amplitude, and going to strike the seashore and creating lot of damage or lot of disaster to the structures present nearby the shore. Beside the tectonic origin of seismic nature, the explosion of volcanoes inside the seawater is also going to disturb the water in similar way, because some of the material here, the volcanic activity is going to aid that suddenly enhance the level of water in the sea, and creating lot of disturbances to reach the equilibrium state of water present in sea in localized zone. Due to this, there is also seismic activity, and such seismic activities is going to agitate the water and creating lot of problem. Initially, the features caused by such seismic activity are almost same as physically observed in case of swell or physically observed in case of wind. However, when such waves is approaching to shore, then there is continuous increment in amplitude, and finally the big waves are, in another words, the waves having higher amplitude is going to strike the shore and creating lot of problems. A seismic sea waves is also known as tsunami, and it is disasters sea waves induced by submarine seismic event occurring less than 50 km beneath the seafloor and with a magnitude greater than 6.5 on Richter scale. Underwater or coastal landslide and volcanic eruptions are also going to activate such seismic activity, and such seismic activities is going to create agitation in water and resulting tsunami waves. The tsunami wave propagate at a speed of 200 meter per second, and the rate at which the wave loses its energy is inversely related to wavelength. As the wavelength of tsunami is higher toward the shore side, then there is generation of huge energy in waves going to strike the shore and creating lot of damaging type of hazards. A tsunami propagates with high speed. It travels a excessive transoceanic distance with very less energy loss. In deep ocean, the amplitude of tsunami is only few feet. However, the speed of tsunami decreases and its amplitude continuously increases with its journey from the deep ocean toward the shore side. Therefore, when the tsunami waves is striking with the shore, then causing devastating force, induced damages, and the power is proportional to the square of amplitude time and the speed. And friends, as you know, the power is dependent on the amplitude, and continuous there is increment in amplitude when the tsunami waves moving from the deep ocean side toward the shore side, and in this way there is a storage of huge energy, and with huge energy the tsunami waves is going to strike the shore and finally creating lot of damage. We have lot of evidences in our past history related to damages caused by tsunami nearby the coastal area throughout the world. Based on wave pattern, particularly the wind blown waves, either in form of ripples, either of higher amplitude, either swell type, except tsunami. Regarding the pattern of sea waves, we are able to categorize the sea waves into category linear waves and random waves. Generally, in shallow sea, the waves generated by wind blowing over the ocean have a range of wave period and wave frequency but not same height, because the generation point have low height. However, when the waves reaching toward the shore side having higher height, and the change in time period and change in frequency of the waves. These variations arise initially from the random nature of pressure pulses acting on the water surface and subsequent complex growth of the perturbations in that of the free surface, resulting generation of waves of higher amplitude and height. Based on linear wave theory, the waves with longer period travels at a higher celerities and that those with a shorter period. Thus, as the wave travels away from the sea area in which they are generated, deep ocean, the longer period waves travels faster and the water surface elevation is more periodic. Such kinds of wave is termed as swell, as we have already elaborated. Waves in deep water and in shallow water, there is no strict distinction between the deep water waves and shallow water waves. The boundary between deep and shallow water waves can be identified on the basis of ratio of water depth to the wavelength. Numerically, we can say that d by L, where L is wavelength and d is depth of water. So, with help of this d and L ratio, we are able to categorize this wave is of deep water waves and this wave of shallow water waves. Waves in deep water, we can say when the d depth of the water is more than the wavelength divided by 2 means 0.5 wavelength, then a deep water waves we are going to recognize, or a short wave occurs and such type of wave we are going to recognize as deep water waves. The speed of deep water waves depends on wavelength, as we have already discussed through this relationship d and wavelength, and the deep water waves show dispersion, and a wave with a longer wave period travels at higher speed in deep water region. The orbits of the molecules of the shallow water moves in elliptical. However, the orbit of the molecules in deep water moves in circular orbital shape. The water molecules in deep water waves moves in a circular orbital shape, and the diameter of the orbit decreases with distance from the surface. Distance means with depth from the surface. The movement of the particles circular, this diameter of the circle decreases when we are going to observe towards the depth side. Here surface of sea and here toward the bottom side. But however, in case of shallow, it is elliptical in nature and same pattern of decrease. The motion is fell down to a distance of about 1 wavelength, where the waves energy become negligible. How the wave we are going to distinct from this deep water to shallow water, or how the deep water waves changes in form of shallow water waves. The change from the deep to shallow water waves occurs when the depth of the water is changing in form of ratio with d by L or d by lambda. So when d is less than 1 by 2 L, or the ratio of d by L 0.5 less than 0.5, there is a formation of shallow water waves, or a long waves, or long wavelength having waves. Their speed is independent of their wavelength and it depends on the depth of water. The shallow water waves show no dispersion. Shallow water waves propagate at a speed which is equal to the square root of product of acceleration of gravity g and the water depth d. So friends, as you know, the recognition regarding the deep water waves and shallow water waves, following the linear wave theory, we can recognize if the d by L means depth of water and wavelength is more than 0.5, then in such situation the wave is recognized as deep water. However, the reverse of this is recognized as shallow water. We have some limit of the shallow water. Between deep water and shallow water there is a transition zone. We are going to recognize as transition water waves. Waves in shallow water, as we have already discussed, shallow water, the orbits of the molecules moves more elliptical, and this ellipticity longer axis decreases when we are moving toward the higher depth. This type of breaking of the waves we have already discussed. When there is any barrier, then the wave starts swelling due to drag effect caused by such barrier, which are not allowing for the faster movement of these water waves toward the shore. However, the top portions, following the inertial concept, started moving fastly. The same case as we are traveling in train. So due to change in speed, sometimes we are feeling some thrust, our heads move forward, but the body is in comparison to head generally less agitated. Similar way here also, the water is the fluid, therefore these upper portions move fastly and the lower portions move slowly. This concept we are going to utilize to define the celerities. The continuous movement of waves run up onto the sloping front of the beach and forming an uprush of the water called as a swash. And when the water is moving back, this zone is known as back swash. This type of breaking zones we generally recognize between 5 to 10 meter depth of the water, and such zone is recognized as surf zone. This breaking of the wave is recognized as surf zone. Regarding the differential speed of waves, we have one typical term, celerity. Celerity indicates about the speed at which an individual wave advances or propagates toward the shore. From a deep water waves, the celerity is directly proportional to the wave period. The celerity is actually defined what is the speed of the wave present on the surface, and what is the speed of this layer of water, what is the speed of this layer of water, what is the speed of this zone. So the speed of this layer of water is more, however the speed of this layer is slightly less, and finally very less. So this relative concept, relative movement of the waves from a point of origin toward the shore is recognized as celerity. And celerity depends on time period and the wavelength. In case of the deep water, you can see continuous decrease in diameter of the orbital toward the depth side. However, in case of this orbital axis, particularly in shallow water, also decreases toward the but elliptical in nature. In deep water, circular in nature. If we are going to see about the derivations related to variation in different parameters, then we have some important notations about the velocity component of the waves, then about the density of the seawater where the waves are moving, then acceleration due to gravity, because all components present on earth governed by gravitational force, and then wave amplitude or the wave height. There is a relation, amplitude is the h by 2, height by 2, and then wave number, which is a ratio of 2 pi divided by wavelength, and wave frequency, which is also the same fashion, but in place of L we are utilizing as a time period. T is a time period, D is a main water distance, and the C is a wave celerity, that is a ratio of wavelength and time period. The generalized equations presenting C waves can be established. Second order differential of this phi with respect to the x, and second order differential of this phi with respect to y direction, as we have already seen in previous diagram. And the solution for this Laplace equation, consider the potential function satisfying equation at the boundary condition where phi is representing Ga by omega cos h k y plus d into sin kx minus omega t by cos h 2kd, where k is the wave number and d is the depth. In similar way, after number of steps, we are able to calculate the wavelength of a wave coming from different depth, and toward the shallow depth, means variation in depth. In deep water, this function L is equal to gt square by 2 pi tan h 2 pi d by L. All terms we have already explained. And celerity is equal to gl by 2 pi tan h 2 pi d by L power half. Such situation in deep water condition where d by L is more than 0.5, the value of this component tan h 2 pi d by L become 1. It means the wave number multiplied by d become 1. In such situation, the wavelength of the sea waves in deep water condition is equal to g into t square by 2 pi. If we are going to put the value of 2 pi, we are going to get, if we are going to put the value of g 9.8 and value of 2 pi, then we are able to get this type of relation. In this way, we are simply able to calculate about the deep water sea wavelength or length by multiplying the time period square with this constant value 1.56. The deep refer to deep water in this equation, and when we are going to determine the celerity is a ratio of the wavelength and time period. So this L we have already calculated for deep water. We are going to put the value of L, then going to put the value of T simply. In this way we are getting Gt by 2 pi, which is 1.56 T. So in this way we are able to calculate about the deep water waves if we are having concept of time period. The deep water waves means originated in deep sea. So a deep water waves going to strike the shore, impact is different. If shallow water waves going to strike the shore, the impact is different. Because the amount of energy in deep water is different and amount of energy in shallow water waves are different. So in this way, in case of shallow water, when this d by L is less than 1 by 20 or 0.04, in such situation the tan h 2 pi d by L is considered as simply 2 pi d by L, and this wavelength we can calculate by this relation L is equal to T in bracket G into D power half, or C is simply under root G into D, means relation of the acceleration due to gravity and depth of water. For all depth, means transition depth, we can determine the wavelength L with relation d by L transition is equal to d by L tan h 2 pi d by L in different situation. In this way, we are going to identify which type of wave is going to strike the shore and what will be the impact of striking of a particular wave, deep ocean wave or shallow ocean wave. One question here, why tsunami waves cannot be identified from far away in ocean? This concept is following this type of derivations. Due to the shorter wavelength and low amplitude in the deep water, we are able to recognize the tsunami because the tsunami have characteristic. There is a continuous storage of energy from initial phase to the final phase, and when this tsunami waves is going to strike the shore, then having huge quantity of energy. Therefore, we are unable to make some mitigations measure to save the community from tsunami. The pressure generated in wave motion can be simply calculated with the this relation of the P pressure into the density of water and acceleration due to gravity. In this simple relationship, we are able to calculate the pressure present in sea waves. The energy moving along the sea waves, we can calculate this energy density of sea water multiplied by the acceleration due to gravity, then square of the height of waves, the wavelength divided by it. In this way, we are able to calculate the energy present in a particular waves which are going to strike the shore. The wave energy is proportional to the square of wave height. Therefore, the waves having higher height is more dangerous in comparison to lower heights. And as per nature, the waves reaching to the shore generally of higher height and causing lot of damage, particularly in case of tsunami. Very high amplitude or very high height. The group velocity we can determine by the simple relation NVN and is equal to the complicated relationship, and the power also can be determined with help of the V. So this group velocity is not of importance. The power P is equal to Vg group velocity multiplied by the density of seawater and acceleration due to gravity, then square of H divided by 8. The important criteria for wave breaking we can determine. In general, the wave will break in shoaling water when its height is approximately 0.8 times the water depth. HB is equal to 0.78 into the depth of water is a criteria we can utilize to know the position or depth of water where the wave is going to break. In case of swelling and in case of wave shoaling, the wave shoaling as per linear theory we can determine the V phase of the wave can be estimated by simple relation GL by 2 pi tan H2 d pi by L power half, as we have already discussed. In this way we are going to calculate about the position or depth of water where the wave started shoaling due to presence of some barrier. Beside this, wave performs diffraction. Due to percolation, due to shoaling, there is a continuous change in the wave features related to amplitude, related to time period, related to wavelength, and this diffraction is going to enhance or change the different features of the waves. This topic is mainly based on the paper written by Holmes P. 2001 on coastal infrastructure design, construction and maintenance. Then partial supports from the book written by Gangopadhyay, term as Engineering Geology, then written by Well F.G. on Engineering Geology and by Kashabulu on Textbook of Engineering Geology. Friends, as per our discussions, in brief, we can say that broadly the waves is classified as wind wave, swell and wave of seismic origin except tidal waves. The role of tidal is in modification of shore is limited in comparison to these three waves and currents, and in deep water the particle moves in circular orbital path. However, in shallow water it is elliptical in nature, and the distinction between deep water and shallow water depends on the ratio of depth of water and wavelength. The shoaling wave, breaking wave and diffraction are the characteristic of shallow waves, and the celerity is the speed at which an individual wave advances toward the shore. Dear friends, in this class we have elaborated about general concept related to propagation of waves from deep water to shallow water and distinction of deep water waves and shallow water waves along with different type of waves like wind waves, shallow waves, swells and the wave having origin not due to wind but due to seismic nature, tectonics, due to volcanic eruption, due to landslide in submarine condition. Thank you very much.